Hello everyone. Today let's look at the graph of some common functions which we will encounter in pre-calculus and calculus. It is very important to understand the graph of these functions as this will give us a clear picture of how the function looks and behaves. Let us start with a simple example of the equation of the straight line, that is y is equal to mx plus c, which is highlighted in red over here. Now over here, the value of m is 1 and the value of c is 0. That means that the graph is y equal to x, and that is the current graph of the equation. Let us now see how changing the values of m and c affects how the graph looks. Let's start with c. As you can see, when I move the value of c around, you can see that the graph goes up or down, depending on the value of c. However, the actual definition is the y-intercept of the graph. That is the point where the graph touches the y-axis, like over here. So c is equal to 3.2 over here, and indeed, this graph touches the y-axis at y is equal to 3.2. Now let us see how m affects the graph. Now, as you can see, when m changes, the slope of the line also changes. And when m is equal to 0, we get a horizontal line over here. And when m is negative, we get a line with a negative slope. We can conclude that m controls the slope of the equation. Now, let us look at another common equation which you will see. Here we have the graph of a quadratic. Recall that a quadratic is in the form of ax squared plus bx plus c. When we factorize it by completing the square, it can also be written in the form of a into x minus h whole squared plus k. That is also known as the vertex form of the quadratic. Now over here, I have a is equal to 1, h equal to 0, and k equal to 0. When I substitute these values in the above equation, we get y is equal to x squared, and that is the graph highlighted in purple over here. Notice that it is a parabola, and so are all other quadratics. Now, let us see what happens when I change the values of a, h, and k, and how that will affect how this graph looks. Let's start with a. When I increase the value of a in the positive direction, you can see that the graph becomes narrower and narrower, and when I reduce a, the graph starts getting wider and wider. When a equal to 0, we get a straight line, because when we substitute it back in the original equation, we just get y equal to k, that's a straight line. And when I put a as negative, you can see that the graph is the same, but it's just facing in the opposite direction. Making a more negative makes the parabola narrower, and making the a more less negative makes the parabola wider. Notice that over here, the graph is concave downwards, and when it's positive, the graph is concave upwards. Now, based on this, we can conclude that A is responsible for controlling the width of the parabola and the direction the parabola opens. Let's look at H now. When I increase or decrease the value of H, you can see that the graph moves along the x-axis. You can see that when the H is positive, the vertex is at a positive x, and when h is negative, it is at a negative x. This defines a horizontal translation. Now, what about k? When I move k, you can see that the graph moves up, it's if k is positive, and it's below the x-axis when k is negative. That means that k defines a vertical translation. Now, one interesting thing to notice is that the vertex of the parabola, its x-coordinate is always equal to h, and its y-coordinate is always equal to k. This means that the vertex of any parabola or quadratic can be written as h, comma k. Let's take a look at another example. Here is the graph of y is equal to the square root of x, or the square root function. Now, I can generalize this a little bit more by writing it as y is equal to the square root of x minus h plus k, which is highlighted in blue now. Now, we want to see how the function behaves when we change the value of h and k. Let's start with h. When I change the value of h, you can see that the graph moves from right to left or from left to right. This means that the graph is performing a horizontal translation. And when I move k around, you can see that the graph moves up and down. This means that this graph is performing a vertical translation at this point. Our final example is the absolute value function, that y is equal to the absolute value of x. Now recall that this can also be defined with a piecewise definition, that is y is equal to minus x when x is less than 0, and y is equal to positive x when x is greater than or equal to 0. The more general form of how to write this is this definition, that y is equal to the absolute value of x minus h plus k. Now let's see how h and k affect how the graph looks. Let us start with k. Now, when I move k around, you can see that the graph goes up and down. This means that the graph performs a vertical translation. And when I move h, you can see that the graph moves right and left. And that's going to mean that the graph is performing a horizontal translation. So again, we have h, the h constant, which is performing a horizontal translation, and the k, which is performing a vertical translation. Let's summarize what we have learned so far. Let's take any function y is equal to f of x and graph it. Here I have taken a parabola, but you can take any function. Let us modify this function by changing x to x minus h. So my new function will be y is equal to f of x minus h. If you graph the function y is equal to f of x minus h, we see that this graph translates horizontally by h units as seen in the graph. Let's recap. This is the graph of f of x, and this is the graph of f is equal to f of x minus h. You can see the horizontal translation applied to the graph.
Okay, stop.
Now let's do the same thing again, but this time, instead of doing y is equal to f of x plus h, let us add a constant k to the value of f of x. Doing so, we get y is equal to f of x plus k, and you can see that that is going to perform a vertical translation to the graph of f of x by k units. Over here, k is negative, so that is why the graph went down. Let us recap. Here's the graph of y is equal to f of x, and here is the graph of y is equal to f of x plus k.
you can see that the graph has been translated vertically by k units. Now, from this, we can conclude that when we subtract a constant h from x and then take the function value of it, you can see that there is going to be a horizontal translation. When we add a constant k to it, you're going to see that there's going to be a vertical translation. And when we do both of them, you can see that there's going to be both a horizontal translation and a vertical translation. Now note that this is possible for every function.